When troubleshooting a phantom voltage issue on switch receptacles, there are several steps to take. Firstly, verify all wiring connections are secure and free of loose or exposed wires. Ensure the black, which is the hot wires, are connected to the brass screws in the switch and receptacle. Verify that the white, which is the neutral wires, are connected to the silver screws. Check that the ground wires are connected to the green screws. Secondly, verify that the arc fault breaker for the affected circuit is functioning properly. Reset or replace the breaker if necessary. If you are still experiencing issues, you can try a different breaker. Thirdly, ensure that the switch is in the off position. Remove the switch plate and check if the switch is making contact with the wires. If the switch is faulty, it may need to be replaced. Fourthly, double-check the wiring connections on the receptacle. Ensure that the contacts are not damaged or corroded. Replace the receptacle if necessary. Fifthly, arc fault breakers are sensitive to inductive loads such as motors and fluorescent lights. If there are any inductive loads on the circuit, try turning them off and checking for voltage again. Sixthly, if the above steps do not resolve the issue, it is advisable to contact a qualified electrician for further troubleshooting and repair. Use a non-contact voltage detector to check for voltage. Always turn off power at the circuit breaker before working on electrical wiring. Wear appropriate safety gear when troubleshooting electrical issues. Phantom voltage, sometimes called ghost voltage or stray voltage, is a phenomenon where a voltage reading is present on a conductor that is not supposed to be energized. This can occur even when the circuit is switched off and there is no apparent load drawing current. Several factors can contribute to this issue. Capacitive coupling is one of them. Adjacent wires running parallel to each other within a cable or conduit can act as capacitors. The energized wire can induce a voltage on the adjacent de-energized wire through capacitive coupling. This induced voltage is typically low, but a high impedance voltmeter can detect it. Inductive coupling is another possibility. Similar to capacitive coupling, an energized wire can induce a voltage in a nearby energized wire through electromagnetic induction. This is more common with AC circuits and can occur even if the wires are not in direct contact. High impedance voltmeters are very sensitive and require very little current to register voltage. This means they can detect even tiny induced voltages that would not be present if a load were connected to the circuit. Floating grounds, if the ground connection is poor or non-existent, the de-energized wire may pick up stray voltages from nearby sources. This is more common in older wiring systems where grounding may not be as robust. Another factor to consider is long wire runs. The longer the wire run, the more opportunity there is for capacitive or inductive coupling to occur. This is especially true if the wires are running parallel to other energized circuits. To troubleshoot phantom voltage, you can use a multimeter to measure the voltage between the de-energized wire and ground. If a voltage is present, it is likely phantom voltage. You can also try connecting a low impedance load, such as the light bulb, to the de-energized wire. If the voltage disappears when the load is connected, it confirms that it is phantom voltage. One thing to consider with arc fault circuit interrupters, which are known as size, are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. A size can sometimes trip due to phantom voltage, as the induced voltage can mimic the characteristics of an arc fault. If the FSI is tripping frequently, it may be necessary to address the phantom voltage issue. There are several things that you can do to mitigate phantom voltage. Firstly, improve grounding. Ensure that all circuits are properly grounded to provide a path for stray voltages to dissipate. Secondly, use shielded cables. Shielded cables can help to reduce capacitive and inductive coupling. Thirdly, separate wiring. Keep energized and de-energized wires separated as much as possible to minimize coupling. Fourthly, use low impedance meters. Use a low impedance voltmeter to measure voltage, as it will be less sensitive to phantom voltage. Fifthly, install surge protectors. Surge protectors can help to suppress transient voltages that can contribute to phantom voltage. When troubleshooting electrical circuits, always follow safe work practices. Turn off the power to the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working on electrical circuits, consult a qualified electrician. It is also important to note that phantom voltage is not necessarily dangerous. However, it can be a nuisance and can sometimes cause problems with electronic equipment. If you are experiencing problems with phantom voltage, it is important to take steps to mitigate it. In summary, phantom voltage is a common phenomenon that can occur in electrical circuits. It is caused by capacitive or inductive coupling, high impedance voltmeters, floating grounds, and long wire runs. Phantom voltage is not necessarily dangerous, but it can be a nuisance and can sometimes cause problems with electronic equipment. There are several things that you can do to mitigate phantom voltage, such as improving grounding, using shielded cables, separating wiring, using low impedance meters, and installing surge protectors. When troubleshooting electrical circuits, always follow safe work practices.